Okay, so there's no one here. Man, it's hot. So this is a great time to talk about the heat index. So the heat index, in short, is human temperature. It's what it feels like. So let me tell you the definition, and then I'm going to show you an example. Okay, so the definition is the temperature it feels like if it was only 20% relative humidity. So there's water in the air. There's water vapor. And so what does water have to do with humans? Let me show you this demonstration. Okay, so I have my infrared camera set up right here. And you can see how hot it is and stuff. And I also have here, see this? It's not cold. It's hot water. I heated it up. This is water. Now I have two sponges. They're dry. Okay. Now I'm going to wet one of them, and we're going to see which one gets colder. So this is with hot water, and I don't want to pour it on myself. Okay, so there, I poured hot water on that. You can see that. See how hot that is. Okay, it's hot. And maybe I made it too hot. Okay, but let me let that sit there for a second, and let me show you how to measure the relative humidity in water. Okay, and I should use cold water again. So here, this is a device to measure the temperature of the air two ways. So it actually has two thermometers here. On one side, it says 40 Celsius. It's pretty hot. 41. And the other side, well, the one side was in the sun. Okay, so I messed this up already. So the other side says 20. Things messed up. It's not a really great one. Okay, let me show you how it works anyway. So what you do is you take this, you spin it around, and one of these bulbs has a wet cloth on it, and that wet cloth, the water evaporates. When water evaporates, it takes energy to go from liquid to a gas, and that energy decreases the temperature. So by looking at the change in temperature for these two things, and a lookup table, you gotta look it up, it'll tell you the relative humidity. So this is one way. There's another way that has two thermometers just like that, and a fan that blows over it so you don't have to look like a fool, swing this around. Okay, let's go back and check on my two. Okay, they're about this, they're close to being the same temperature, but if you look up here where the water has dried off, it's actually cooler, right? There's parts of this that are actually cooler than this, and I poured really hot water on this one. So water evaporating cools things off, and that's an example of this right here. And in fact, just for fun, see, look, I'm putting it on my shirt. See, I'm not sweating. You can't see that in the camera, but in the infrared camera, you can see it. So look how cool that is, okay? And that too, see? That's me actually sweating. Is that gross? Whatever. Okay, so let me tell you how to calculate the heat index. So it's really crazy. You got to measure the temperature and the relative humidity and then use this. So this is a formula that depends on the temperature, the relative humidity, and a bunch of coefficients, T squared, R squared, and so forth like that. So it's kind of complicated. But I have here an example. Suppose that the temperature were 94 Fahrenheit and 75% humidity. That would give you a heat index of 124 Fahrenheit. So that says that it could be 124 degrees Fahrenheit and it would feel like 94. Okay, if it was 20 degrees, 20% relative humidity at 124 degrees. Now, you can actually have the heat index lower than the temperature. I think that's pretty cool. Suppose that it was 95 degrees outside at 10% humidity. In that case, it would feel like 90 degrees. It would feel, because the water off your skin is evaporating and it cools you off, so it gives you the feel temperature. But that only works for humans. Okay? And that's only a measure because everyone sweats differently, and then you have other factors like wind and air and sun and stuff like that. So, but that's an introduction to the heat index. And I'm really hot and my head's all shiny and wet. Okay, I'll talk to you guys later.